Hello Year 11s. For today's lesson we're going to be learning a new topic on a subject called cracking. But to start off with, what I'd like you to do is put today's date in your book, and you're going to pause the video after you see the questions, and you will have 6 minutes to answer them. They're past paper questions, but you don't need to write out the question. So here we go. So just to help you, the table shows you the molecular formula over there and the boiling points of 4 alkanes. The first question, describe how the boiling points of these alkanes change as the number of carbon atoms in one of the molecules change, for 1 mark. In the second question, calculate the relative formula mass of a molecule of propane using that information. Propane reacts with excess oxygen to form carbon dioxide and water. Write the word equation for this reaction. And question 4, explain a problem caused by incomplete combustion of propane, and that is for 2 marks. So pause the video for 6 minutes and then you can restart to purple pen your answers. Okay, so the first question, describe how the boiling points of these alkanes change as the numbers of carbon atoms in one of the molecules change. Now, this is just asking you to show the pattern that you see here. So, as the number of carbon atoms increase, you can see here going from 3 to 6, what is happening to the boiling point? It is increasing as well. So 1 mark for that. In the second question, this is a reminder of a previous topic, calculating the relative formula mass of a molecule of propane. So you've got to take into consideration that the formula tells you you've got 3 carbon atoms and 8 hydrogen atoms. So carbon has a mass of 12, so 3 times 12 is of course 36, and you've got 8 times 1 of hydrogen, so that's 44 in total. A nice easy mark there. Okay, moving on to the next question. Write the word equation for this reaction. So you've got propane reacting with oxygen. So that's quite clearly your reactants. Be careful, don't write air, because air isn't a chemical, it's a mixture. And it forms carbon dioxide and water. Also don't fall in the trap of writing a balanced symbol equation if it's asking for a word equation. So that's 2 marks, 1 mark for getting the reactants correct, 1 mark for getting the products correct. And your final question, explain a problem caused by the incomplete combustion of propane. Right, so what did you put for that one? So there's actually quite a lot you could put here. And it says here an exclamation that combines the identification, so showing you the understanding and the justification. So identification and understanding is important. So what you could say is you could identify carbon monoxide formation as a problem, and you could say that it is toxic, or it restricts the amount of oxygen carried by the blood. As it's only 1 mark, that would be absolutely fine. Any mention of carbon dioxide doesn't get you a mark. Any mentioning of it's dangerous or harmful is not enough scientific detail to get the mark. You can say, if you made a mistake and you said methane, or you said gas, they will allow 1 mark only. Okay, now the second point, because it's incomplete combustion, you're going to get carbon as well. So carbon, smoke or soot will give you 1 mark, and the explanation is that it damages the lungs, it causes breathing difficulties, it can choke people, It could block fuel jets, it said over there as well. They would allow, and you could even say less energy is released, because we know that less energy is released, but that is very lucky to get a mark for that answer. So, couple of combinations you could get for that question. Okay, so let's move on to today's lesson. I will tell you when to pause and write down some notes, but first I'm going to explain this to you. So we know that through fractional distillation we get some very, very long chain molecules, and sometimes those long chain molecules are not as useful as the smaller molecules. So how do we go from a long chain molecule to a smaller chain molecule? Well, it's quite simple. If I've got something long and I want to make it smaller, I simply I crack it. Okay, and in order to crack it, I need to put in energy. So I'm going to put in some heat. So this process of cracking is when I take the large fractions and I break it in a structure called a catalytic cracker. So that tells me that I need a catalyst, and it cracks it, it breaks it up by thermal decomposition. So thermal decomposition is when you have one reactant and you use heat to break it into two smaller products. So one reactant and two products is a clue that I'm using decomposition, and if I'm using heat, it's known as thermal decomposition. So what happens is we take that long fraction, something like decane, and we heat it, and as it's heated it vaporizes and it passes over that hot catalyst, and it causes the molecule to split apart into smaller molecules. Now the key thing to remember with cracking is that with those two smaller molecules, one of them is always going to be an alkene. Remember, alkenes have the double carbon bond between one of its carbon pairs. Okay, what I'd like you to do is pause the video and copy this heading and bullet points. Okay, right, so really important for you to take into your concept, into your brain, is that the way of making sure we can get those high demand short chain hydrocarbons like octane is by cracking. Okay, so obviously petrol is used a lot for cars. So how can we take some of those long, less useful molecules and turn it into something like octane? And that, of course, is by cracking, which you've just written down. So let's have a look at a picture, because sometimes a picture explains this to us better. So over here I've got a 4-chained hydrocarbon called butane. I know it's butane rather than butene because there's no double bonds. And this can be cracked, and I could end up with ethane, and I could end up with ethene. So notice 4 gets broken into 2 plus 2 carbons. That's really important to remember, because they could give you something with 12 carbons, and then you could break it into, let's say, 6 and 6, or 12, you can go 8 and 4. Okay, so as long as one of the molecules is an alkene, you can't go wrong. So let's look at this example. Decane is heated at 800 degrees Celsius in the presence of the catalyst aluminium oxide. And what happens, you can see here the decane, C10, has broken down into octane, and here's my alkene. Remember, an alkene is always formed. And that's where they can ask you about the properties of the alkenes, the properties of alkanes, how they can test for it as well. So what I'd like you to do is pause the video and copy this equation, please. Okay, so really important to remember that an alkene is always formed in the cracking reaction. Okay, now this experiment can be a little bit scary, so I'm going to explain to you how we do this. So over here, I am going to heat a long chain molecule like paraffin. And what I do is inside this boiling tube, I've added some broken pot, which is my catalyst, aluminium oxide. And you can see I'm heating it. Remember, cracking involves breaking down due to heat. So as this vaporizes and passes over the catalyst, due to the heat in the catalyst, it's going to break down, and the gases are going to move along these boiling tubes and delivery tubes. So over here I have some liquid hydrocarbon collecting. That's why I have some cold water to condense the gas. And I also collect some of the gas that's formed, so the gas displaces the water. So as it's, some gas is collected, the level of water goes down, down, and down. And we can test that gas. So what I'd like you to do is I'd like you to copy this diagram using a ruler and pencil for diagrams. Remember, I want you to use the labels in pen and with a ruler for the label lines. And then what I'd like you to do is I'd like you to jot down the answers to these questions. When you are done, you can restart the video. Okay, let's have a look at some of the answers. So the type of reaction is thermal decomposition. Why are the pieces of broken pot used? Because they act as a catalyst. Why? To speed up the reaction. So remember those whys to try and get a deeper answer. Why does the beaker contain cold water? To condense the liquid hydrocarbon. And why can the gas be collected in this way? Because it's less dense than water. So this would be your longer chain molecule, this would be your shorter chain molecule. What molecules could decane, be cracked to form? So octane and ethene, but equally if you had put hexane and butene, that would have been absolutely fine. Now, a couple of things to question you on. How would you know that an alkene is being formed? Pause the video and discuss it with your neighbor. Okay, so the question was, how would you know that an alkene is being formed? Well, what you would need to do is you would need to bubble that gas through some, do you remember what the test was? Yes, well done. It was bromine water. And if it was in fact an alkene, it would go from an orangey brown color to colorless, and that would tell me that I have a unsaturated molecule like the alkene. Okay. One more very, very important point that I want you to make a note of. Sometimes this experiment, I said to you, can be a little bit scary. If I stop heating the boiling tube, what will happen as the gas particles become closer together because it's cooling? The liquid from the upside down test tube over here gets sucked back into the tube. That's called suckback. And why suckback is so alarming is because the moment that cold water hits the hot test tube, it could cause the test tube to explode. Now, the way that we prevent this happening is we make sure that we remove this tube before we turn off the heat. That way, none of the liquid in here can be sucked back. So we actually just remove this entire boiling tube out of the water. Okay, I have seen that question asked in a few exam papers. So, nothing like a practice paper to see how you're doing. So on the screen next, I've got a couple of past paper questions. I want you to pause the video